Hi, everybody. We are starting lesson 4, and we are going to graph lines. But instead of my line having just a line and only the ordered pairs that are on the line are solutions, what I'm going to do is I have an inequality, and an inequality means that there's no equal sign. That in my equation, I'm going to have, instead of an equal sign, a greater than, a less than, greater than or equal to, less than or equal to symbol. And that symbol is going to be how I know where my solutions are. So we're actually going to say that, this equation means this line, and that all of the answers, all of the ordered pairs that would plug in for my x comma y, all of those ordered pairs are in this shaded region. So there's many, many, many ordered pair answers that are going to be solutions, not just the dots on the line. All these dots here and 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 here. Get it? Okay. So linear inequality is going to be a graphed line with solutions in a certain area. Now remember, pause the video if you need to rewrite the definition, or if I'm going too fast, or you need to look over something again, rewind the video and watch it again. Like, you need to make this work for you, right? So my solution means any ordered pair in the shaded region. Okay? These are all solutions. Every dot, whether it's marked or not, here, 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 these are all solutions to this inequality. Now we need to make this inequality into y equals mx plus b, and that's what we're going to practice today. So here we go. All right. Check whether the ordered pair is a solution of 2x minus 3y is greater than or equal to negative 2. In case you forgot, this means greater than. This, and then this one, these are less than. So we might need that refresher. And L, when it's shaped this way, it makes a less than symbol, like L. Look, I'm a loser if it were on my forehead, right? All right, A. So we're going to plug it in, 2x. X is 0, y is 0. Minus 3, y, 0, is greater than or equal to negative 2. 0 minus 0. Is 0 greater than or equal to negative 2? Is 0 bigger than negative 2? Yes, it is. So 0, 0 is a solution. And look, 0, 0 is in the shaded area up here. This equation matches this graph up here. Part B, 0, comma 1. All right, 2 times 0 minus 3 times 1 is greater than or equal to negative 2. 0 minus 3. Is negative 3 greater than or equal to negative 2? Well, negative 3 on a number line, guys. Let's do it over here. If here's negative 3, here's negative 2, right? So which one's bigger? Well, negative 2 is bigger. So this says, is negative 3 greater than negative 2? No. That is not true. Part C, 2 comma negative 1. So I plug it in for 2x minus 3y is greater than or equal to negative 2. 2x minus 3 times negative 1 is greater than or equal to negative 2. 4 plus 4 is greater than or equal to negative 2. Is 8 greater than or equal to negative 2? Yes, it is. Okay. So this is the practice of us plugging in ordered pairs to see if it's a solution. If I didn't feel like graphing, I could plug in an ordered pair. It's kind of like a shortcut way to do it. All right, here we go. Graphing a linear inequality. Graph the corresponding equation. It's going to be in y equals mx plus b. Use a dashed line for inequalities greater than or less than to show the points on the line are not solutions. When it's a dashed line, then a point on the dashed line is not a solution. Points on the line are not solutions. Okay? Then it says, use a solid line for inequalities with a greater than or equal to or less than or equal to show the points are solutions. When it's a solid line, points on the line, this point or this point, are solutions. Oh, you can't even see that. That's one thing about not being in the classroom. No one can say, Mrs. Grant, I can't see it. So then you draw, the line you drew separates the coordinate plane into two half planes, into two sections. We can test a point to find out whether it's a solution. You pick a point, but I'm just going to teach you how to shade. And then if you're going to shade less than, if it's under. So let's practice that. Less than or less than or equal to is going to be left of the line or under the line. If it's greater than or equal to, it's going to be shading is to the right or above the line. And I'll practice this as we get on to the examples. Here we go. When graphing on a coordinate plane, the inequality symbol tells us what kind of line to draw. Less than and greater than is going to be a dotted line. Less than or equal to, greater than or equal to is going to be a solid line. All right, so this is all the basics, the meat and the bones. Keep this paper handy, and we're going to go to the next page. Okay, so here's what I need you to do on the top of this paper. I need you to write that this or this is going to be a dashed line. Less than, greater than, dashed line, dotted line. And then if it has a or equal to symbol underneath it, it's going to be a solid line. Now we need to remember that we will have arrows at the ends of our line. Okay, so now let's do numbers 2 and 3. It says, sketch the following graphs. X is less than negative 2. Okay, well, there's no y in this. This is not in y equals mx plus b form, which means it's not going to be a slanted line. It's either going to be horizontal or vertical. So on the x-axis, go to negative 2. And let me, let me make this a color. Here we go. This x is less than negative 2 is going to be solid or dotted. Look at this inequality symbol right here. Is that a dashed line or is that a solid line? Did you say dotted? You should have. Okay, so you go to negative 2, and it's going to be a dotted line. So I'm using just purple. Now, it says less than. Where's less than this line? Remember, less than or equal to is going to be lower, under, or left. My shading is going to be less than this line, lower, left. There's no under the line because it's a straight up and down line. That means that this point is a solution to x is less than negative 2. As is this point, as is this point. Oh, wait, how about a point on the line? Nope. Not this point on the line because it's a dotted line. This is a solution. This is a solution. And this, and this, and this, and this. Get it? All the points in the shaded area are solutions. There's so many, thousands and thousands and thousands of options. Okay, let's go down to number 3. Y is greater than or equal to 1. Is this going to be a solid or a dotted line? Look, it says greater than or equal to. Go back up here to the top of my paper, greater than or equal to. Oh, solid line. On the y-axis, go to 1, and then you're going to make a solid line. Now, this says greater than or equal to. Okay, so our shading, let's go to the left side. If it's greater than or equal to, it's going to be above the line. The shading will be above the line. The shading will be to the right side. So here, greater than the line, above the line, all this. This is a solution. This is a solution. This is a solution. This and here. How about on the actual line? Yup. On the line is a solution because solid lines, points on the line are solutions. Okay, so those were just easy. I had a vertical line and I had a horizontal line. Now I'm actually going to do a y equals mx plus b. So y equals mx plus b. Here we go. Number 4. Y is greater than negative 2x plus 3. My m is negative 2 over 1. My begin is at 3. My y-intercept is 3. So now I'm going to do begin at 3. Y-intercept is at 3. Let me do purple again, My y-intercept is at 3. And then I'm going to rise negative 2, run 1. From this dot, because rising negative 2 means I go down 2 and right 1. Down 2, right 1, make a dot. Down 2, right 1, make a dot. Please reverse it. Up 2, left 1. So I have my dots. Now I need to connect the dots. La, 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 la. Should I make it a solid line or a dotted line? Look right here. What does that mean, solid or dotted? It means dotted. So, dash, dash, dotted, dotted, dotted. Okay. Please make lines, arrows at the corners. Now the shading, this right here, symbol, says greater than. So greater than is above the line, to the right of the line, higher than the line. This is all above the line, greater than to the right of the line. All of these ordered pairs right here, boom, 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 are solutions. Okay. Now I'm going to have you graph a line with me, and then we're going to talk about how to figure out if it is like what the equation would be. Okay. So here's what I want you to do. Draw it along with me. Okay. Here we go. All right. I want you to put a dot at negative 1. Gotta keep doing this purple, don't I? Put a dot at negative 1. Then I want you to put a dot at 2, 0. Then I want you to put a dot on the other side, negative 2, negative 2. I want you to connect this line with a solid line. Then I want you to shade it here. Okay. Our job is, what's the equation of this line? What is the y equals mx plus b of this line? So I'm going to begin at negative 1. See, that's my y-intercept. Then I need to find my slope. So I want to know, how did I rise and run? How did I go from here to this dot? What did I do? So rise 1, run 1, 2. So rise 1, and I run 2. All right, now that's my M and my B. Y, I'm not going to put equals. 1/2 x minus 1. I'm going to put like a less than or greater than or less than or equal to or greater. So now I gave you a solid line and I shaded below it. A solid line means what? Dotted, or I'm sorry, a solid line means like less than or equal to. If it's a solid line, it's going to have an or equal to symbol underneath it. Now I shaded under, below. That's where the less than comes in. So it's going to be less than or equal to. I shaded underneath and it's a solid line, less than or equal to. All right, so your homework tonight is going to be some problems on Pearson, and they will be assigned to you online. All right, and this is 4.4a.